righty, here we go. Have a little calculator device out here for this first one. Okay, here we go. We got to move on. We did 2 days of rectangle and rhombus, 3 days of a parallelogram. Let's finish off that family right now and talk about a square. All right, a square. Here's the definition of a square. Everyone remembers your rectangle, right? So here's a rectangle. How do I make a rectangle into a square? That's it. 2 consecutive sides. Why don't I need the other 2? Opposite sides are congruent, so we assume that they're all congruent. Yep. So if you want to make a rectangle into a square, that's what I do. Let me challenge you right now. What if I had a rhombus on my hands and I wanted to make it into a square? What do you think I would need to add into our rhombus to make it into a square? So there's my rhombus. Scott, what do you think? Less. Less. You said all angles congruent, meaning they're all what type of angles? 90, right? So I only need one of them because I already know the opposite and consecutive ones. All right, so that's all I need: a rhombus with a right angle or a rectangle with 2 consecutive sides congruent. Now notice I only have 2 properties up there, but did you remember where the square was on the family tree? Where was it? Where was it underneath? Parallelogram, rhombus, and rectangle. So instead of listing out all those properties, because the square has every single property we've talked about in this class since the beginning of the unit, the square has every single one. So just to make it easy, the 2 properties are all rectangle properties and all rhombus properties. Anything we have discussed, this square has. A square has all of them. That's a lot of properties, huh? Just for one figure. That's why it's the golden one. All right, let's try one out. This one's going to be a tough one. Buckle up. Maybe the power of your group will help you out. I don't know. 1 diagonal, 16. We all know diagonals, corner to corner, vertice to non-consecutive vertice, 16. What's the perimeter? Just so we're all good, I don't want to assume anything. We all know what perimeter here is. All 4 sides added up, but what do you know about the 4 sides? It's a square. No, sides. What do we know about all 4 of the sides? It's a square. They're all what? Congruent. So if I just find one, I could just multiply by 4 since they're all the same. All right, let's talk about this as a class because I don't want you to go back to your group on this one. All right, what else can I do? I got to find a side so I can multiply it by 4. Remember, it's a square. Anything goes. Anything goes. What's up, Zach? All the angles are right angles. Okay. Yeah, you're right. I'll put that on if I need it. Yeah, I may. Luke, you got something?
You could do a squared plus b squared equals c squared, and since the 2 are this, well, you can't really, yeah, never mind. Because I was thinking because they're the same, you could do something, but then I realized.
Put that on hold. We may come back to Pythagorean theorem. Because what type of triangle do you need for it? A right triangle. Doesn't this figure have 2 diagonals? What do you know about them when I draw the other one in? Remember, every property exists here. Go ahead, tell me something. They're going to bisect each other, and they're going to be congruent, right? So everyone remember the 16? These 4 pieces are going to turn into what? 8, 8, 8, right? 8. Everyone see why? They're congruent and they bisect each other. 8, 8, 8, and another property of diagonals I'm still looking for. Perpendicular. They're going to form a right angle. Now I can do what, Luke? There we go. Now I can do Pythag. I just had to get the diagram correct first. So a squared plus b squared equals c squared. Where are the 8s going? A, B, C, A and B. because C is always the one across from the right angle. 8 squared plus 8 squared equals C squared. What do I have? 64. 64. What do I have? 128. And what do I still have to do to both sides? Square root. I know there should be rounding directions. Can we just go nearest 10th here? Nearest 10th, square root of 128. 11.3. I'm trusting you on that. And now that's one side. What'd you tell me to do to find the perimeter? Multiply it by 4. Or add 11.34 times. So 4 times 11.3. Even though you think it's nice that the square has all these properties, the problems are tough because you got to remember all the properties to apply. Any questions, comments, concerns? All right, Shocker, what's up next? Coordinate proof. Let's do it. All right, ready to roll? Got a graph? This is a 2-part question. First part, let's prove it a rhombus. Prove it a rhombus. All right, how do we prove a figure is a rhombus? What property did we just show? The easiest one for us. How are we going to show this is a rhombus? 9. 10. Hello, Josh. Okay, all sides are congruent. Going back, Josh, what formula am I going to need? All right, everyone ready? 4 distances. Make sure they're all equal. Good news here. You don't have to do distance for 2 of the sides. Why not? But we got to prove that though. Why am I saying 2 of the sides I don't need to use distance? No. Can I just count how long AT is? You don't need distance to do that one. How long is AT? 5 units? Count it. That's what I mean by you don't need distance. MH, how long is it? 5. Done. Now you're going to have to use distance formula on AM and TH though. Oh, by the way, just so we're all clear, this doesn't fly with me. You do those 2 and you're like, I know the other 2 are going to be 5, so I'll just write 5. Baloney. You show me how you got 5 if you can't count it. All right, that's not going to be accepted. I know some of you get sneaky that way. That's not going to fly. Show me how you get 5. So we plug it in. Changing your x's here. Let's see, where's AM? -2 minus 1 all squared plus 5 minus 1. Show me why it comes out to be 5. Don't just write a 5 down. I'm going to be like, no go. So what do you got? 3 squared and 4 squared? Still with us here. So what number do you get underneath the radical? What's the number I get underneath the radical here? Don't answer. I'll ask somebody. When you're ready, what number do I get underneath the radical? 11. 4.
So you get 9 plus 16, which is the 5, which is 5.
There you go. 25. 5. Yep. Should get the square root of 25 underneath, I hope. All right, one more side, right? What's our last side? TH? X's, subtract your X's, subtract your Y's. Hopefully you get 25 out again.
Yep.
All right. Step 2. Let me know. What did you just learn about your sides? It's not a rhombus yet. Let's go. 17. What did we just learn about the sides? All right. So tell me, AT is congruent to MH. Is congruent to, you guys got it, AM, congruent to TH. Because, how do I know all the sides are equal? 23, what did we just do up here to make all sides equal? Perfect, because distances are equal. Don't tell me because it's a rhombus. We're trying to prove that. The word rhombus shouldn't come up to the end. Like right now, right? Math is a rhombus. Because? Why is this bad boy a rhombus? Talk to me. You guys are doing a nice job. Oh, here again. 1. Hi, George.
Because all sides are congruent.
You were ready to rock on that one, huh?
Yeah.
It's about time. I've only been here 4 months. Good job. Ooh, whoa, we're not going on to the next one.
Yeah, you're right.
This was a 2-parter, right?
You gotta prove it's not a square.
Now show it's not a square. All right, well, let's talk. How am I going to do that? Think about a square and what a square has. And we got to show it doesn't have one thing that a square has.
Let me see.
What's a square have that we can prove this one doesn't have? Oh, right angle. Good, I like it. But do I have to do all 4? No, just 1, right? So let's show there is not a right angle at angle H. All right, let's show there's no right angle at H. What formula am I going to need now to show there's no right angle, which usually is formed by perpendicular lines? Slope formula. All right, so here you go. Step 4, we're going to have to find this. If you're going to find that H is not a right angle, it's going to be what 2 lines now? Slope of TH. Let's start there. Slope of TH. Go ahead and find it. Rise over run. Up and over. Slope of TH when you find it. 20. Good. -4 over 3. It's negative because it's going downhill. And I also have to compare that with the slope of MH. Ooh, oh. Quick review. MH is a horizontal line. Any horizontal line always has a slope of 0. Vertical? No slope. Vertical line, no slope. All right, MH is a slope of 0. All right, what can we, are these 2 perpendicular? If I got a slope of 0 and -4/3, perpendicular or no?
No.
Okay, let's say it. TH. And you watch, ready? Look at this fancy. Perpendicular? Nah. All right, slash right through. TH not perpendicular to MH. Why? How do I know they're not? How do I know they're not? Oh, 4. Because slopes are not. There you go. So can this be a square?
No.
All right, so let's say that. Math is not a square, and why? Woo! Math's not a square because, how do we know? Why wouldn't this be a square? In your own words. 11s? Don't have one. 19? Thank you. Math is not a square because, well, I don't want to say no right angles. I only know one spot where there's not a right angle, right? I haven't proved the other ones are, and I don't want to, so get more specific for me. Correct, because angle H is not a right angle. I can't say because all of them are, because I haven't shown that yet. The only thing I'm positive on is that angle H is not a right angle. All right, good work, kids, good work. Any questions, comments, concerns about the square? Square out of the way, we're done with the parallelogram family. Let's go on the other side of the family tree to the good old outcast, which is the kite. All right, why is the kite different than everybody else? No parallel sides at all. None. None. Everyone see my markings on my kite? It has two pairs of congruent sides that are adjacent to each other. Does it have any opposite sides that are congruent? Any opposite sides? No, the congruent sides are always adjacent to each other. All right, you ready for the properties? All right, let's do this. In a kite, one pair, not both, one pair of opposite angles congruent. Uh-oh. Oh boy. Now what's your question? Yeah, which pair, right? How am I ever going to figure out which pair are congruent? Do you see where the non-congruent sides meet? Yeah. Everyone see the two angles that are formed by the non-congruent sides? What are they in our diagram? BN, that's where your congruent angles are. It's where the non-congruent sides meet. So in our case here, this would be angle B, congruent to angle D. Correct. So B and D would be congruent. That's it. Now, that's the only pair. That is it. It's the pair formed by the non-congruent sides. All right. So we got a pair of angles that are congruent. Next property. Can I still have diagonals in a kite? Do you think? Can I still draw in diagonals? Where would C go? All right. And where would B go? All right. So I do have two diagonals, and they have a property. What do you think? Certainly not congruent, but they are perpendicular. Diagonals are perpendicular. So they form a right angle. Yep. Do you see that one is longer than the other? Does everyone see that? One diagonal is longer than the other? Well, guess what? The longer one's kind of a bully. The longer diagonal bisects the shorter. All right, the longer diagonal bisects the shorter one. The kite's tough because we're used to diagonals bisecting each other, all angles equal, but now it's only certain pairs. And you know what? I'm not even going to write in number 4. We won't need it. All right, so I'm just going to stick with these 3. You guys have enough properties to remember now. So I'm going to go with these 3. All right. Okay, so let's use them now. Let's use them. Ho! Ready? How can I find angles 1 and 2? Anything we know about them before we start? Look at our properties. Anything I know about angle 1 and 2? They're congruent at least. So whatever I get for 1, I'm going to get for 2. So I know they're congruent. So I know angle 1 is congruent to angle 2. Done. All right, how am I going to get there? Oh, boy. I really just don't want to give it away. I want you to try to think about this here. Got something, Zach?
Yeah, we can figure out what's the, I forget the word for it, but the measurement of all the angles combined.
So you're saying, what do all four angles add up to?
Yeah.
And then I can find the angles. Well, it's a quadrilateral. Anybody remember that off the top of their head? Quadrilateral is how many degrees in it? 360, yeah. 360. So what we can do is what? 101, ready? 101 plus 48 plus 2, or x plus x, right? We can write 2x because they're both the same equals what? 360. There you go. Yep. Any quadrilateral, it's equal to 360. You guys typing away. One and two are? 17. Angles 1 and 2 both are?
I don't have my calculator.
Problem number 1, 2, 4. 105.5. Don't sound so enthused. Okay, good there. All right, let's go to 2. Angle 1 should be done right now if you look at your properties. Angle 1 should be 90 degrees. Yep. So angle 1's 90, diagonal's perpendicular. All right, what about 2? Can we get to 2? Remember, hey, and wasn't angle 1 90? What's right next to it? Another 90? And don't I have 90 and 27 in the same triangle, and 2's the third missing angle? Yes! How about the missing angle 2 now? Oh, 19 on fire.
It's 63.
63? Question so far before I get to angle 3. Rick, what? Okay, this right here is a right angle via, right? Because it's next to a right angle in angle 1. You see the triangle with angle 2, the right angle, and 27? They have to add up to 180, right? So that's how we got it. Okay, 180 degrees in a triangle. All right, you ready for angle 3? Because this is going to be a tougher one. This was going to be the 4th property I was going to write down, but it got too long. In a kite, because adjacent sides are congruent, do you see what type of triangles they form? Oh, they form isosceles triangles, right? What's across from the congruent sides? Which would be 2 and 3. Everyone see, in a kite, it forms 2, if I draw the shorter diagonal in, 2 isosceles triangles. So across of the congruent sides are congruent angles, which would be, 63 degrees.
Wow, I never knew that.
And we do have some time right now, so in your group right now, discuss 3. Go ahead, discuss 3 in your group. Use all your properties. Mark things down that are blank. How do I get to x? Now you know it's isosceles. Forms are diagonals, perpendicular.
I think you forgot.
All right, so first, diagonals are perpendicular. The top triangle is isosceles. So if that's 8x, we also know this angle is 8x. Now we know all 3 angles in a triangle. 90, 8x, and the 5x minus 1 all equal up to 180. All right. And x on this one comes out to be 8 when you're ready. Take your time.
Is it 20.7?
20.7. Is that what it came out to be? I have 7.
Yeah, I have that too.
Move the 88. Move the 89 over. 180 minus 89, right? And then you divide both sides by.
13.
Yep. 7.
Yeah.
All right. You good there, Molly?
Yeah.
Make me nervous there. Other questions? All right. We don't have time to do that kite one, but keep going with the homework on the next page now. Talk it over with your group right now. Start on page 38 with that square problem. Here you go. Work right up to the bell, please. Right up to the bell.